In this video, we are going to learn how to calculate linearized stress in SimSolid. This feature is available as a post-processing option for static analysis, and it decomposes elastic stress field into membrane, bending, and peak stresses. For the purpose of this demo, we have a pressure vessel model which has already been set up and solved for static analysis. Let's take a few seconds to review the model. It has a total of 61 parts. And connections are well established between all the parts of this assembly. The model is constrained on either ends, and a pressure load is applied inside the vessel. And it is solved for linear static analysis. Now let's see how to calculate linearized stress. To open Linearized Stress window, click on Pick Info and switch to Linearized Stress tab. Linearized stress is calculated along a line segment, and SimSolid allows a couple of ways to draw this line. The first one is normal to surface. In this case, pick a point on the model, and SimSolid draws a line segment by projecting a ray normal to the path surface. And the next one is custom option. In this case, you can pick points on the model to draw a line segment. Let's first look at normal to surface option. Pick a point on the model. A local coordinate system will be created with its x-axis along the line segment. And linearized stress is calculated on the fly along this local coordinate system, and values are posted in the lower section of this dialog. By default, invariants are shown in the table. You can choose to check this option to view other stress components. Now let's take a look at the second method of drawing the line segment. In this case, we'll see how to draw a line segment at the max stress region. We'll make use of the saved view to orient the model and cut the model using clipping plane to view along its thickness. Switch back to Linearized Stress tab and switch to custom option. Pick the first point at the max stress region and the other point along the thickness of the model. Similar to first line, linearized stress components are printed in the table. These calculated values can be saved to a CSV file using Save to CSV option. SimSolid also allows setting up a failure criteria to check if the invariants of linearized stress are within the allowable limits. The defaults you see here for failure criteria are based on the yield stress of the material. These values can be edited at any time. So let's edit one of the values and set the membrane stress to 115 megapascal. Now all the cells of invariants with membrane stress higher than 110 megapascal are highlighted in red, and the status of the line changes from pass to fail. If none of the invariants are above the specified failure criteria, the line status continues to show as pass, as in the case of second line. Thank you for watching.